In this experiment, our objective was to measure temperature change using different sensors. Using the different sensors, we obtained data for each type, and they can be seen on the graphs on the next slide. When we were cooling the water down from 45 degrees centigrade, there was a slight difference between the first experiment and the other two. This could be for a number of reasons, including the initial temperature being higher than 45 degrees, or even human error when measuring the temperature. At 10 seconds, the same kind of result is observed, where experiments 2 and 3 is the same, whereas 1 is slightly lower. The final reading at 15 seconds shows all three results the same. This could be because the temperature has reached its lowest in terms of the cooling aspect. The average for heating is the same for 2 and 3, but for 1 it's slightly different due to the change in the other temperatures at 5 and 10 seconds.
5 seconds, experiment 1 and 3 have reached 40 degrees from 5 degrees. Experiment 2 has only reached 37 degrees. Between 5 and 10 seconds, all three experiments have reached 43 degrees. Between 10 and 15 seconds, experiment 1 and 3 have reached 43 degrees, and experiment 2 has reached 44 degrees. The average heating temperature for experiment 1 and 3 were 42 degrees, and for experiment 2 was 41.3 degrees.
The sensors we used was PT100 reference, the thermostat, naked beam thermocouple, and PT100 industrial. As you can see with the PT100 reference versus time, when the system got cooled from 40 to 0, there's a dramatic spike down until it stabilized at around 20 seconds. On the other hand, with the PT100 reference versus time, when the system got heated from 0 to 40, there's a dramatic spike up and it stabilized around, again, 20 seconds. The same trend follows for the PT100 industrial, as you can see. With thermostat versus time, there's a positive correlation between time and thermostat when the system is cooled, and there's a negative correlation when the system is heated. With thermocouple versus time, when the system is cooled, there's a negative correlation, yet when the system is heated, there's a positive correlation between thermocouple and time.
So the accuracy is not reliable due to the fact that we had to rely on the human eye to do the recording, and we had to do full readings in a span of 10 seconds. And it was difficult to do it in a specific time, and it was lost to the surroundings.